Scale. It's a tricky subject, and it's a term that, when not well contextualized, can lead to all kinds of confusion. From talking about the protective outer layer of snakes and fish, that's one type of scale. For measuring weights or bringing things into balance, another definition of scale. But where geographers come in and use the word scale, it is used generally to describe about the size or the magnitude of something, or its reach or impact across space. And that space might be real, it might be imagined, it might be virtual, but again, the scale talks to some effect about the sort of scope or the size over which some phenomenon is measured or impactful. In cartography specifically, sort of the core and heart of what people think of when they hear geography, the word scale is used as cartographic scale, where it is a ratio that relates the size, or let's say the length of something that we measure on a map or a representation of reality, relative to its real world dimension. So we might see things like 1 to 10,000 or 1 to 50,000 as a cartographic scale on a map. And it tells us that if we measure something on the map in some units, millimeters, centimeters, or inches, then we multiply it by that factor to get its real world dimension in the same units, which means we can take the size and the complexity of the real world and bring it into a representation that is much more compact and smaller, so that we can carry around a map rather than having to try and represent the world at its full size and scale or scope. That's cartographic scale. And where it gets tricky is that when we talk about large cartographic scale, we mean a ratio where the numerator to denominator provides a relatively large number, so 1 to 100, 1 to 1,000, something like that, as compared to small scale, where the ratio resolves to a much smaller number. For example, 1 to 1,000,000 or 1 to 250,000, where those numbers are much smaller. The key thing here is that a small cartographic scale means that we're representing a very large geographic area, but with less detail. And a large cartographic scale means that we're representing generally a smaller extent, a smaller area, but with potentially more detail. The confusion that ensues is that if you are an ecologist or a biologist, a field technician, we often have the opposing definition for how we use the word scale. That is, large scale tends to mean large geographic extent or large area, and small scale means something that's localized or on a small geographic space. So when we talk about using scale, it's useful to prefix it with the word ecological or biological scale, or prefix it with cartographic, so that we know how to interpret the value that we're talking about. And for us, we need to make sure that when we are bringing data sets together and making analyses based on them, that we're doing things where the scales of measurement are consistent. Otherwise, we're going to have incongruencies in how things make sense. The world is an inherently complex thing. And if we were to ignore the idea of scale, we may find that we're measuring some aspects of the world at one scale and other aspects at another, which makes those not fit together in our analyses very well. Let's take, for example, working in a forested environment, and we are working very much locally at the individual plant level or maybe the individual leaf level, and we're tracking things that are happening on this absolutely sort of fine scale to try and understand what's happening in terms of gas exchange or moisture exchange at the leaf level. And we're trying to make assessments as to what's happening in terms of photosynthesis. That's working with one sort of level of measurement. But for us to then try to sort of expand that to a national level measurement, it's a very different scale of data measurement and observation. And we might do this at different spatial resolutions. I mean, that gets into a whole other ballgame. But we can't measure that level of detail nationally. It's just an impossibility in terms of our data collection ability. So when we think about characterizing geographic space, when we think about scale, when we think about measurement, we really do need to make sure that the measurements that we're making are in agreement with one another. And it's a way by which we can take the complexity of the world and sort of boil it into a range of variability or expectation that we can make measurements on, so that we don't overextend our interpretations or miss some key ingredients because we've got our scales incorrect.